Good day, everyone. In this presentation, we're going to be dealing with probability theory. All right, in this presentation, review data and statistics. We're going to talk about central tendency, a little bit of dispersion, but we're going to do a lot of probability talking. Reviewing statistics. All right, we talked about what data is. We know that data is a number that tells a story. But we know that statistic is using data to inspire change. All right, a statistical question basically have various answers. So I'm not gonna read this to you. You guys can read this on yourself. But however, we are interested in the distribution and the tendency of those answers. So we're looking for the mode, median, all this, all that. The examples include: what's your favorite food? What's your favorite game? Again, if you pay close attention, you know that these questions will have answers with different variation of answers. Make sure you have it. Make sure that you understand this because this is something that I test for and every other definition. All right. So on this quiz, you gotta know the precise definition of mathematics, which is the technique to teach, learn, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Statistics. Statistic is the technique, or statistics, my bad, is the technique of collecting, organizing, analyzing, and interpreting data to make decisions. This is what those definitions are. Please know them. Please know the difference to it. And remember, when it comes to statistics, you are to make decisions on them. All right. All right. You guys, for the most part, have been hooked, claw, line, sinker into the news, and you've been into it. And you know, this is what I'm looking for in terms of the news. So when you do your test, I need for you to give me a complete thought like this. Sunday, it's another decent weather day, starting off cool in the upper 70s, but quickly warming into the mid 70s this afternoon under partly sunny skies. This is a complete statistical statement. It pretty much tell me all about the weather. According to the police, Jarek Washington was identified as a victim in the highway shooting. These are good statistics that we need to hear about. All right, so make sure when you do your quiz or a test, make sure you give me a good thought. Right? Central tendency. This pretty much deals with three things to talk about your data set. So data set is a collection of all the data that we collect. For those who was with me, we have dealt with measuring heartbeats, and we recorded the data and we recorded all of it. I mean, recorded and the collection of all that data is called a data set. The mode, we know the number of colors the most, mean, the average, median is the middle number. Right? When we get back from spring break, we're gonna have all the details to talk about in this. So we have previous class periods. Took these data set and we put in the calculator. But also, in some classes, not all, I put it in decimals. So again, I will post a video to show you how to do that, but I'm not gonna do it in this presentation. So everything that you need, this is something that I'm gonna be expecting you to do in a project. So I will give you a project that you have to do, and that you have to be able to learn how to produce. Probability are the outcomes for a specified event are called the favorable outcomes. When all outcomes are equally likely, the theoretical probability of the event can be found by using the following. So, long story short, the theoretical probability is what is supposed to happen. For example, if I was to flip a coin, I should know that if my heads should be 2, and my tails should be also 1/2. So basically, they are equally likely, so they have the same equal chance. And it's just like flipping a 5 on a single die. So if I do that, I know I got a 1 out of 6 chance to do that. And that's with any die. I have a 1 out of 6 chance to get it, which is equally likely for all of them. There's no crazy conditions, just that. So if you're good, you're good. If you got any questions, y'all please see me. All right, experimental probability is based on repeated trials of a probability experiment. So the number of trials is the number of times the probability experiment has been performed. For example, when we was rolling the dice in the classroom, say we had 10 people, and I told those 10 people to someone had to hit a 3 and a 6 in the die. So out of the 10, 4 of them actually hit it. So the probability is 4 out of 10. That's the experimental probability. All right, what is probability? So probability is the technique to measure risk and uncertainty. So probability is measured using numbers from 0 to 1. So when we mean by 0 and 1, 0% or 0.00-1. Like for example, if 4 out of 5 people pass the test, that means 80% or zero point 0.8 is probability of those passing the test. All right. So when it's closer to 0, that means it's unlikely something to happen, such as correctly guessing a stranger's birthday. In fact, you are much more likely to guess someone's birthday incorrectly. The probability of guessing the birthday incorrectly is close to 1. So in that example, it talks about, like, for example, my birthday. None of you guys will know my birthday. Okay, what's probability continuing? So when determining probabilities, the possible results of an action is called the outcomes. What are the possible outcomes? So the outcomes are these things, like when we're shooting a die. Sample space is the set of all possible outcomes. It's called a sample space. So 1 through 6, that's just an example. So you're listing all the possible outcomes, and that is called a sample space. An event is the set of outcomes. All right. So again, when you think of outcomes, you think about those events, and that's what it's called. All right, a set of those outcomes. All right. What is the probability? The probability of an event happening, which is written as this. Again, the outcome is called the event. All right. So when you say the outcome, another word for that is the event. So And this is how you find the event. Make sure you get all of this down situated. All right. The fathers of probability. It is essential to know these people. Because these are the people who created probability. Blaise, or Blaise Pascal, and Pierre de Fermat. These are the two mathematicians who made probability what it is today. Both of these fathers were mathematicians, and there was gamblers. All right. Again, gambling pretty much define what probability is. Both changed how scientists. What I mean by that, both of them changed how scientists and mathematicians deals with risk and uncertainty. So, because of that, we had different perspective of how we deal with risk and uncertainty. Because life, you gotta kind of define that. It wasn't well defined until those two people came in and put it together. Use gambling to define the probability. So again, these two use gambling to really to define what probability is today. Statistics and probability is the youngest of all the mathematics. Now, although I'm teaching you about gambling, one thing that I want to share, I want to make it certainly clear. Gambling is not allowed in school. So that means we're not playing for no money. You should never do that. Um, we play for silly prizes like points or whatnot in the classroom. All right. Again, this next quiz is pretty much about facts. And you're going to have a little math to deal with this quiz, but I need to know that you know how to factor and know these basic probabilities. So, probability laws, mutually exclusive events, can never occur at the same time. So, these are laws that are set in motion, cannot be changed, cannot be cannot be challenged or anything like that. So, for example, if we talking about flipping a die, right? Singular for dice. On that one die, can you have both even and odd number on that die? No, you cannot do that. Because if you do that, guess what? It becomes a problem. And it's non-existent. So therefore, it's a mutually exclusive event. And there are going to be some examples of this. So when we say probability A or B, the or piece means addition. So it's probability A plus probability of B. A complement of events. In probability, we say what is not. Complement means not. So when we say a probability of A not, we go 1 minus probability of A. So whatever the probability of A is, you're going to, subtract it from 1. So 1 minus that probability. All right, so here's an example of what I'm talking about. So you spin the spinner once. What's the probability of it not being odd? Not being odd. When it's not odd, well, we know the probability of it being odd is 1/2. So 1 minus 1/2 equals 1/2, and we know 1/2 is going to be 50%. So in this example, what's the probability of 6 or even? So ask yourself this question. When you're picking a card, can it be 6 or even? So yes, it can be because it is 6. And not only just that, it's also even. So it's happening at the same time. And because it's happening at the same time, you're not going to use that other probability stuff we did in the previous example. You're just going to take the probability of it. So the probability of that 6 or even, which is just 6, it's going to be just 1/3 in this case. Right. So you pick a card at random. What's the probability of it being 8 or less than 7? So why don't you pause and try it? Just look at it and just try it. All right. By now, you have attempted this problem. You have done so cool. You have not. Pretty please, 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 please. Pause the video and do it. You should have gotten it 2/3. Because you realize that if it's less than 7, you're going to get this. There's two of them, two cards. If you got any further questions, see me, we could discuss the matter. What's the probability of it of P has being heads or tails? All right, so look, this is a little tricky. So the card was a little bit more easy. This one, heads or tails. So what's the probability of it being heads? It's going to be 1/2 for both of them because we use the word or. 2/2 makes a whole, so the probability is going to be just 1. So now this is going to be unique. So you have to consider this to be pretty unique. What's the probability of P being even or odd? So if I was to pick a card, can it be either even or odd? Because any of those. So if I was to pick a card, can it be both even and odd? No, it has to be one or the other. Because of that, you gotta find the probability of it being even. 2 and 4 is even. So that's half. So that's 2/4. 2/4 equates to 1/2. Odd is 1 and 3. So 1/2 plus another 1/2. 2/2 makes a whole. Independent events. Two events are independent when the occurrence of the other does not affect the occurrence of the other event. Example, when you roll a die and flip a coin, they got nothing to do with each other, so therefore they are independent. It could happen at the same time if things does not change. All right, the probability of A and B being independent events if and only if the probability that both events occur is the product of the probabilities of events. Two events are dependent otherwise. So basically, what they're saying is if probability of one thing times another probability of another thing equals the combined probability of them both, it is independent. It looks it's much more easier than said. Okay, so let's do this one. If in the experiment the probability that A occurs is 3/4, the probability of B occurs is 1/4, and the probability of A and B occurs is 3/16. Are A and B independent events? Probability of A and B is 3/16, right? So you want to see does the probability of A times B equals the combined probability of both A and B, which is 3/4 times 1/4, which equals 3/16. So because both these are equal, therefore it's independent. So with these problems, you just have to look at it. And you just have to know what goes where. Remember, it's probability of A and B equals A times B, or probability of A times B. Let me say that. But that's how you do all that. And I will send you guys more practice if need be. All right? So you guys could be all right. All right. Conditional probability is probability that B occurs given that A, the event has occurred. So look, so this is one of those things that is better just said than explained. So the conditional probability of B given A is written as this. So when they ask you the probability of B given A, it should be A given B. But we're going to apply this. So don't pay attention to this right now. Just follow what I'm going to tell you. All right? Ready? All right, so let's do this example. I know I wrote the answer there, but I'm going to show you the details. In the experiment, the probability of A occurs is 5/7. The probability that B occurs is 5/6. And that the probability events that A and B both occur is 5/9. What is the probability that A occurs given B occurs? So in this case, you are given this formula to use. Probability A and B over probability of B. To take care of this, you should look at the information given to you. So at the end of this, I know it says that the events A and B both occurs 5/9. All right. And then the probability of B, which that's what I'm using, is 5/6. So for this particular lesson, you're going to be using this formula a lot. So 5/9 divided by 5/6. And when you divide this in, you're going to get 2/3. So you trying to figure out how I got 2/3 is keep the 5/9, change the multiplication to division, reciprocate, other words, and flip 6/5. So when you multiply that, 5's cancel out. So 6/9 simplified to 2/3. And that's how I got my answer. Again, because it says given B, you just put in the formula. So what I can do to help you guys out is just leave you with the formulas on those things. All right. So this is pretty much just it, what we've done throughout the week.